it's almost time, but let's see. Okay, number of people is getting increased. Okay, I can wait 1 or 2 minutes. Okay. Okay, looks like we can start, right? Okay, so let's start the session. Hello everyone. I hear some echoes somewhere. Okay, hello everyone. I think I can hear you. You can hear me. Um, so this is a TCPM working group meeting, TCP maintenance and minor extension working group. And this working group has 3 co-chairs. My name is Yoshi Nishida, and then we have Ian here and Michael here, everyone in remote. And just in case this session is being recorded, so it will be published eventually. So if you are in a remote, make sure you have already cleaned the room. Otherwise, it will be published. Okay. And this is user not well. I think you have already seen this several times already. So in a nutshell, this basically describe how to participate, how to contribute to the IETF, and which point you should be aware of. And if you have any concerns about participating or contributing to the IETF, please read this slide very carefully. And then if you can find the same content on the IETF webpage. You can search and you can find it very easily. And then, so this is a special tips for this IETF meeting. So if you are on site, please make sure to sign in the session by using Meet Echo. And also, when you speak up, please use Meet Echo to join the mic queue. And please keep audio and video off uh, while unless you are using on-site version of Meet Echo. And if you are remote participant, please make sure your audio and video off unless you are not unless you are speaking, and then use your headset as much as possible. Okay, and then this is a resource for this IETF meeting. Uh, you can find the entire agenda on this first URL. And if you want to get more information about Meet Echo or other information, you can use the second URL. And if you have any technical issues or other issues you want to report, please use the third link. Moving on, logistics. So Richard will be in charge of note taking. Thank you so much, Richard. And Michael will take care of JavaScript. Thank you so much, Michael. And this is short reminder. So when you submit your internet draft to this working group, please include TCPM as the name of your draft. Otherwise, we cannot track the status of your draft. So please keep this in your mind. And then this is agenda for today's meeting. So we are starting from working group status. And then after that, we have 3 presentations for working group document. At first, Praveen will talk about high-stat draft. And then um, BD will talk about the cubic draft. After that, Bob will talk about accurate ECN updates. And after working group documents presentation, we have 3 presentations for non-working group document. First, Carlos will talk about TCP accurate request. And then after that, Peng will talk about update for MPTCP lobby. And then after that, Maxim will talk about TCP-LS, modern transport service with TCP and TLS. So this is the agenda for today. Any question or comment or suggestion on this agenda? Okay, then moving on to the working group status. So as you might already notice, there are some personnel updates in the working group. And very unfortunately, Michael decided to step down as a chair. But we really, really appreciate his long-term contribution, dedication to the IETF and to this working group. Um, I really, really appreciate it. I learned him a lot. I learned from him a lot. And then we have a new co-chair, Ian. And thank you so much for taking this role. Ian, you have some words?
Thank you. Yeah, I'm really excited. Obviously, I'm extremely familiar with Quick and to congestion control work like BPR and such. And I'm excited to kind of get a better visibility into the innovations in TCP and um, help wherever I can to make sure that TCP is as awesome as Quick. So that's kind of how I think about it.
Thank you. Okay, moving on. So working group documents. So we have several working group documents. So AO test vector draft. The current status of this draft is RFC in EDITA queue. So this draft will be published very soon. So Young TCP draft. This draft is under IESG review now, and then current status is revised ID needed. And then 793 bis draft. This draft is currently under ISG evaluation. And 8312 bis draft. This draft will be discussed in the meeting, and so hopefully we can finalize this draft. And high start plus draft. And this draft will also be discussed in the meeting. And then accurate ECN draft. This draft will also be discussed in the meeting. And then we believe all three these drafts getting close to be finalized. That's expectation. And then generalized ECN draft. This draft has been on hold for a while. And the reason why it has been on hold is that this draft depends on accurate ECN. But we have very long discussion on accurate ECN draft. That's why this general ECN draft has been suspended for a long time. But I think the current status of accurate ECN is getting matured. It's getting close to be finalized. So I think we can start proceeding general ECN draft very soon. That is expectation. And for EDO draft, Joe sometimes updates the draft, sometimes send a message to the mailing list. But the problem of this draft is we don't have many feedback on this draft. So it's very difficult for chairs to think about how to proceed this draft. So I would like to talk about this draft a little bit more in my final slide. So I will talk about this later. And then the final one is 6937 bis draft. This draft has been inactive for a while, but as far as we exchange email with the author is planning to publish a new version very soon. And so once they have published the new version, we can think about how to proceed the draft. So that's a plan. So that's the current status of the working group document. Any questions or comments on the working group documents?
So this is Richard Schaffenegger, just a general observation. I don't think we need to wait with generalized ECN on any of the other stuff, really. Quite the opposite. So I would really appreciate it if generalized ECN would proceed. Perhaps we can start thinking about even going working group last call, because quite frankly, I don't see any technical discussion going on around that, while there is also technical merit to be had from generalized ECN.
Okay,
Thanks.
that's fine. Okay, then Richard, you can initiate mail, send an email to the mailing list, and then initiate discussion, and then we can think about if it's ready for working group last call or not.
Bob?
Yeah,
Oh,
just in response to that, that would be fine. It has a normative reference to accurate ECN, so it could go through to the ISG, but it would sit in the ISG queue waiting for accurate ECN if it went first. But that's it might be better to get it out of the way rather than putting the both at once. Can you not hear me?
it's a little difficult to hear you. Sorry.
So
Ah,
if you can improve your settings before the presentation, that would be great.
so what's the problem? Just volume?
No, it's not volume.
Only cutting out, I think. At least that's what it was for me.
Okay.
Better now, at least for
Well,
me. I'm not sure.
quite know how to do anything
Now it seems
differently,
better.
but okay. Right. Okay.
Okay. So
You hear what I said about what Richard said?
If you can repeat it with this.
Okay. I just said that there's a normative reference from, in generalized ECN to accurate ECN. So it would be fine to go through the group bus call and start processing it. But if it did get approved by the ISG, it would sit in the ISG edited queue, which would be fine. At least it would be out of the working group. But that
Okay.
possibly sitting there.
yeah, I, basically I got it. It's a little tricky. So
Sorry.
somehow, yeah, that's okay. Okay, let's move on to the next slide. So this is my final slide. So I'd like to talk about EDO draft a little bit more. And as I mentioned, the problem of this draft is we have very little feedback on this draft. So what I'm thinking right now is, we can, have some kind of specific reviewer for this draft. And then if we can get very detailed feedback on this draft from the reviewers, we can have a very good idea about how to proceed the draft. So if you are interested in reviewing draft, this is a very good chance for you to speak up. So anyone interested in reviewing this draft, please speak up right now.
I think I could at least read it and see whether I can offer anything.
Okay, great. Thank you so much, Jonathan. It will be good if I can have one more reviewer, if possible. Okay. Yeah, if not, after some discussion among chairs, we might contact some of you for asking, reviewing. But that's a plan. And then also, if you have some implementation experience for EDO draft, or if you plan to implement EDO draft, please share the information. Such kind of information will also be very useful for us to think about how to proceed this draft. So we appreciate your cooperation. And then in the meantime, I also would like to think about how to proceed Shin option extension. And Joe has a one proposal about the Shin option space extension. And this problem, the problem of this draft is also we have very little feedback on this draft. And then Joe is saying that he is thinking about submitting this draft as an independent stream. But I'm not sure this is a great idea. The one reason for that is Shin option extension is very fundamental for TCP spec. So having this kind of proposal as an independent stream is a great idea or not. But we still don't have a specific feedback on this point. So we don't know if this is okay or if this is not okay. Well, we should adapt it as this is a great idea. So, and then we also would like to think about how to extend Shin option space in general, not only specific Joe's proposal. If you have any idea or opinions, thought, please share. So we really appreciate your feedback. Any comments or thought? Wes?
Yeah, I would say the options extension in general and the SYN especially is something I've been interested in for a long time. And ideally, I think the working group would handle this and arrive at a consensus solution. I think the independent stream path is a last resort if the working group doesn't have the interest or energy to do anything. I think it makes sense to me because it comes up enough that something is needed, that the independent path is a way to get something published that other people can use and experiment with. But I think it's a last resort and it's not the ideal path at all.
Thank you. Martin?
Hi, Martin Duke, Google. Yeah, I mean, I agree with Wes. It would be nice to get this done. And if it's a question of bandwidth, just people want to review it, but there's too many other things in TCPM right now, then maybe we can make a commitment to, like, I don't know, adopt it and then clear some space that people have the time. Or if people just aren't interested, that's maybe a different issue. So I'm not sure what the nature of the reluctance is.
Yeah. Yeah, so I also need more, at least I need more feedback. Otherwise,
So this is Richard. So from my observations over the last couple of years, we've had a couple of years ago, we had this push to get more option space, and it was quite a high on the agenda. But since then, we didn't really find anything that had an immediate need for extended options right away. However, I would support what Martin just said. I think we should discuss adopting this and having it on the working group's agenda, because eventually it will be coming up again, and then it will be more urgent than ever, probably, at least in the beginning. At least at that time, I would expect that people will have some bandwidth to contribute and review.
So you are saying we should wait a little bit more, or we should start discussion very soon?
I think we should adopt. I think we should adopt this, but and give it consideration, just as Martin mentioned, and to see that we can work on this, even not at a very high priority right now, but eventually it should be a working group document. I don't think that. I also believe what Wes mentioned. Having it as an independent stream should only be the very last resort, and I wouldn't really like that.
So I do want to clarify that I was making a question, not a statement. Like if the lack of reviews is like indifference or bandwidth. And if the question is bandwidth, then I think we can make time for this and just maybe reduce our document intake or whatever, and then put it as like the last milestone. They're the furthest out milestone. Whereas if people just like don't care, then we shouldn't string along Joe. Thanks.
Mhm. Okay, thank you. So if there is no more comments, now we are moving on to the presentation.
I would like to ask the presenters to stay in the time they got for the presentations.
Okay, let's move on to the presentation. So Praveen, it's your turn.
Can you hear me?
And you should share yours. You can control your slide
I sent
from
a
Videco.
request. Thank you.
I just approved it, Praveen.
Great. Hello, everyone. I'm here to talk about HiStart++. So the current draft version is draft version 4. This is a recap of the original idea when we first brought this to the TCPM working group. So the problem we're trying to solve is the slow start overshoot problem. So because we effectively double the window every round trip time, we can overshoot the ideal send rate, and that causes massive packet losses, which means more time spent in recovery, as well as increased packet retransmissions. And sometimes we end up taking RTO even with algorithms like RAC. So HiStart++ originally, when we proposed it, was a very simple modification, and the idea was there to use delay increase to detect that the queues are filling up, and we basically exit slow start early before causing the packet loss. And then we included a compensation for any premature slow start exit. So in cases where the delay increase was due to jitter or a temporary burst of packets, we basically introduced usage of limited slow start. So effectively, we would use the max of limited slow start and the congestion avoidance window, thereby mitigating some of the impact of a spurious exit. At that point, we got some feedback and we started looking into jitter resiliency, and we ended up simplifying the algorithm a lot. So instead of trying to compensate for early exit from slow start, we added detection of spurious exits to be able to resume slow start. So imagine a network where there is a lot of jitter, a delay increase algorithm would kick in sometimes spuriously and cause us to exit slow start. At that point, we enter something called as the conservative slow start phase. So what is conservative slow start? It's basically a series of rounds where we are trying to determine if the exit was spurious due to a delay spike. And the way we do that is when we enter CSS, we capture the current round's min RGT at that point, and then for a series of rounds, we see if any of the delay samples are going to be lower than the captured RGT. That tells us whether the delay increase was spurious or not. And if we think that if we determine that the exit was indeed spurious, we basically resume HiStart++. So which means regular slow start resumes, as well as the direction of delay increase, and the entire algorithm is basically reset and it restarts. And the advantage of this is that if the network does have jitter, that slow start will still give you good performance and an exponential window increase. So that's the gist of it, that instead of trying to compensate for early exit, we are detecting spurious exits and we're resuming slow start. Sorry for the small font size here, but this is the summary of the current algorithm in draft version 4. So basically in slow start, we adjust the congestion window according to 5681, but we take RTT samples. So each round is approximately an RTT. And we remember the last round's min RTT, and we compute the current round's min RTT. And we use a threshold, basically. There's a lower clamp and an upper clamp. But basically, if the current round's min RTT is greater than the last round's min RTT plus the threshold, then we exit slow start. We also capture something called a CSS baseline RTT. So that's the RTT I was talking about that will help us determine if the exit was spurious or not. And then the conservative slow start phase lasts a few rounds. Currently, the draft recommends 5 rounds based on experimentation. And then for each ACK in CSS, again, we repeat the procedure where we continue to measure the current round's min RTT, and we compare that against the captured CSS baseline RTT. And if at any point during CSS we see that the current round's min RTT goes lower than the CSS baseline RTT, at that point we can determine that the exit was actually spurious, and we just resume slow start and high start plus plus. But if we complete all of CSS, if we complete all those rounds and we don't see the min RTT go lower than our captured RTT, then we basically enter congestion avoidance. So that is actually a correct exit, and there is a consistent delay increase. We do exit high start plus plus on any congestion signals. And currently the draft recommends that we only use this for the initial slow start. For subsequent slow starts after RTO, we do have a value of captured SS thresh, and we say that you may use this after idle. So we did make a few changes in draft. I want to bring up a couple of things that were brought up in the mailing list. Randall had proposed that instead of setting CSS baseline RTT to the current round's min RTT, that it instead be set to last round min RTT plus RTT thresh. We did experiment with this idea, but it showed poor performance when jitter was present. So I think it was an optimization for when there's no jitter, but in presence of jitter, it did not work well. And I think Neil had suggested that we use a different mechanism for determining window end. Basically, instead of using greater than or equal to, use strictly greater than. I think his comments were going towards cases where we could be app limited. But we found that this is also inaccurate computation of end of round in many cases, so we did not make this change. So the only sort of logic change that we made in draft 04 was removing dependency on low SS thresh. So basically at this point, the only trigger for computing and measuring the RTT values and looking at delay increase is basically enough number of RTT samples have been taken in the round, which currently the draft recommends that the implementation at least take 8 measurements of RTT. So that was the only change. So that simplified things a little bit more and removed one magic constant. And then we made a bunch of editorial improvements based on all the discussions in the mailing list. So at this point, we have addressed all the outstanding reviews. I think we got one from Bob, Jeremy, and Neil so far. And we answered questions on the mailing list as well that came in from Randall and Neil. And to our awareness, there are at least 3 implementations in production use. The Windows TCP cubic implementation has been using this for more than 2 years. I think maybe more than 3 years at this point. Cloudflare's quick library quiche uses it in production, and then FreeBSD has also added this to their TCP cubic implementation. So in the author's eyes, I think the draft is ready for working group last call. And I'm happy to take any questions.
Gory, would you like to go first?
So, Gory Fairhurst, thank you for doing this. I've seen this in action. It can be good. My question is, which of the implementations use the latest version of the spec? Is there one I could actually go and try over my awkward paths that I now know about? And interesting.
We seem to have some small voice interference from Ian's direction.
So I'm looking for a pointer to which version of the code I should test, and then offer to try and test it and see how well it works over some really awkward links as useful feedback, perhaps.
Yeah, Gauri, so the latest versions of the Windows OS, both Windows 10 and Windows 11, have the latest algorithm implemented, and I think the FreeBSD TCP implementation also uses the latest draft. So both of these include, for example, all the conservative slow start phase and all of that. The Cloudflare's quick library, I'm not sure if it has been updated to the latest draft.
That's what I wanted to know. Thank you ever so much. I'll give you feedback.
Thank you.
Any other comments? So I think, this stuff has been stable for a long time. And then I think, we are almost getting ready for working group Rust code. That's what's currently Chair's thinking. But if you have any opinions, thought on this one, this is a good chance for you to speak up. Any comments? Silence understands there is no objection. Am I correct? Okay, seems to be, at least there is no objection. I think we can confirm if this is ready for working group Rust code later on the mailing list. Okay, thank you, Praveen.
Okay, sounds good. Thank you, Yoshi.
Okay. So moving on to the next presentation. Billy?
Hi, can you
Always
hear me?
just test my audio. Can you hear me now?
Yeah, you want to make some comments?
No, no. I just wanted to check that you
Or
could
you are
hear my
testing?
audio.
Okay. I think it's getting better.
Okay.
Yeah.
Can you hear me okay?
Yeah.
So sorry, so I always forget the slide request.
I think
Palush.
you already granted.
Okay. Could you tell me where was it, on the left or the right? Has to. Okay, got it. Okay. Share. All right. Can you see the slides now?
Mm-hmm.
Awesome. So today I'll talk a little bit about, the changes that have been made, and then the discussion that was happening on the mailing list to publish cubic bits as a proposed standard or something else. So I have captured some of the updates in these slides, but there are many more. These are just some of the updates that I thought would be interesting to just combine in the slides, and this includes everything that has been changed, plus the ones that I have not added here. So they're all present on the GitHub. I'm not going to go through each one of them because we have gone through these in the past presentations. So I'll give just a couple of minutes on each slides if you have any questions, just in case if you haven't seen these updates so far. Same here. These were also done and discussed in the previous presentations. Give a couple of seconds here. So since the last meeting, we made some changes, and these I would like to discuss. The spurious congestion, detecting spurious congestion event and reacting to them. There's now we have categorized into two events. One is spurious timeouts, and the other is spurious loss detected by acknowledgements. The first one is kind of relevant for TCP, and there's already a standards track RFC that specifies the response for restoring the congestion window and for adapting the timer so that there's to avoid any future spurious timeouts. So there's this RFC 4015 that specifies all of that. And then we have the spurious losses detected by acknowledgements. So this is relevant for both TCP and QUIC. And in TCP, you can use timestamps and duplicate secs to detect these. Excuse me. For QUIC, it's quite easy. You can detect it by seeing any new packets. Sorry. You can see this by detecting any packets that were marked lost, but they were acknowledged after they were marked lost. So that's kind of a spurious loss. And then for these events, right now we have suggested doing undo of the congestion window, of the slow start threshold, and a few more parameters for cubic. So and this one is kind of has a caution written in the text to be careful when you're using this, because it might cause you to set congestion window to a higher value if the link capacity has changed from the previous state to the now state. So you just have to be a little careful with that. And then we have Neil actually made the next update about clarifying the meaning of application limited. There was some question about what does application limited means, and we have added text for clarifying that. And then there was a request or question by Yushi about why is RFC 7661 okay to use, when RFC 5681 has a specific text about congestion window growing beyond receive window, that it shouldn't grow beyond receive window. So the 7661 basically is monitoring bytes acknowledged in RTT, like the pipeback value that it's computing. It's doing how many bytes are acknowledged in consecutive RTTs, 1, 2, or 3 rounds. So because it's based on the pipeback value, which is bytes acknowledged in RTT, it kind of includes validates the receive window, because you always check the receive window before sending the data. So we have added text to make it a little bit more clear why it is safe to use, even when this congestion window grows beyond receive window. So these are the latest updates in the draft. And this is probably the main topic for today. I will. I will leave the rest of the time for questions, discussions, and comments on whether we should publish 8312 bits as standards track or not.
Gory?
Yeah, Gory first. I was going to talk to the previous slide and just say, I'll read the text again. I think I was happy with what was done. So the 7661 thing, I think they did the right thing for this document. So I don't see that as an issue, and I'll read the text carefully, I promise, and give feedback if I see anything. So from my point of view, let's look at the last slide.
Okay, any comments for PS or experimental?
Michael?
Michael Wetzel, just a quick question about this last statement here, this separate draft on cubic evaluation or improvements. Is that supposed to be the home for the things that Marco has brought up?
That's supposed to be.
Okay, I was just curious. I think it's a good idea, probably.
And if anyone else has any other improvements that they wish to talk about.
Lars?
Hi, yeah, Lars Eggert. I saw a bunch of emails from Marco on the list that I haven't fully had the time to read yet, but glancing at it, I'm not sure if he's okay with publishing this as PS, even if we did this other document. I would like to hear that validated from him. I think what I saw him say is that because Cubic was deployed on the internet without this, not following the process that we did back when I was Magnus and me were AD, and then we had Sally and I think was it Wes work on this considerations thing, means that the IETF cannot do this before Cubic undergoes all of this, evaluation. And then while I was instrumental in establishing this process, and so I wish that deployment would have happened that way. It didn't, right? People deployed Cubic and it worked well enough, and more people deployed Cubic, and now it's basically ubiquitous. And I sort of see two ways forward, right? Either we can acknowledge that and say, well, this didn't happen in the way we ideally would have envisioned it to play out, but the reality is that it is running the traffic on the internet, and therefore maybe it should be PS. Or we can say, we're not willing to do that, and we're going to stick with New Reno. And I personally, obviously, I'm very biased here because I think this should be published as standard, but I think it would be good to that seems to be the fundamental sort of objection, right? That it's didn't do what we expect, specifically new congestion control algorithms, which is arguably isn't really either, but the process that we expect the stuff to undergo, and it didn't follow that. Right. I will point out, I made the comment in the bar the other night that maybe I'll write another document that says we should declare New Reno historic because we don't have any deployment experience on the running internet anymore, and we haven't had it for 10 years. But that's a discussion for another day.
Cory?
So this is great. It's Cory Fairhurst again, and I get to agree with Lars really positively on the first one, which basically I think we should write a paragraph of text saying we didn't do it the way the IETF should do it. This is not totally consistent with other RFCs, but it is running code. It is out there. It is the consensus of what to do, and that's what this document is. And if we have a process to doing that, then I think we should go that way. If we don't, then I think we need to invent one because we need to get this document published. So that's my own take, and that's just an individual idea. The second thing is I don't agree with Lars on the on Reno, so we can fight that one out later.
Michael?
So Lars brought up a statement that there is a process how to deal with new congestion controls, and so obviously Cubic didn't follow that procedure. Considering another congestion control algorithm which is being deployed called BBR is also not following this procedure. So I'm wondering whether this, how important should it be to follow this procedure? And just to answer Martin's questions on the chat, Netflix uses New Reno.
Gore, are you still in the queue?
Cory, you are in the queue?
He's trying to exit.
Hi, Lars. I just went back into the queue and then I saw there's other yellow things in front of me. So, I mean, the history of this process, right? This is when, I don't want to call it the high-speed congestion control wars, but it was basically, we had lots, I think 4 or 5 different proposals, many of them from academia on, how you can improve TCP specifically for what's called high-speed links back then, which are just normal links now. But back then they were high-speed because they were like a gig fast or something like that. And we felt that on the IETF side, we needed to give this some guidance and some structure because it was sort of quite confusing how people went about sort of motivating why their scheme was better than somebody else's scheme and all of that. And that sort of, that's not how congestion control is being done or brought to the IETF anymore. But we're now in a situation where the people who work on new congestion control schemes actually are in control of endpoints directly, which wasn't the case back then, right? It's mostly academic work that smart people did, but they didn't have the ability to deploy at scale, which we now have, right? And so it's a very different world now, 15 years later, where we actually have the ability to do A/B testing over the real internet and get data back and all of that. So, and we've seen this when we did IW10, for example, and other things, right? So the process we outline is probably not useless in the sense that it still gives you good guidance for what the IETF would like to see, but maybe like requiring that to be followed hasn't aged very well.
Okay. Can I say something? So, yeah, I think, basically I agree what Michael says. So BBR is internet draft. So it's not, it might be experimental. So I don't know the status. But for example, RFC 9002, this is proposed standard. And then I also think this is some kind of aggressiveness in the draft, the algorithm described in the draft. So I think I don't find a particular reason that we are attacking cubic specifically. So there are several drafts, and they all drafts should be treated equally. And then otherwise, it's not very fair. And so I just, if we, we set the high bar on the cubic draft. I think there we should set all other kind of congestion control draft should be has the same bar. That's my personal opinion. Praveen?
Yeah. So I tend to agree that this should be proposed standard just because of how widely it is deployed. And I think if I were writing a new TCP implementation or even a quick implementation, like having Cubic as the standard to implement would make sense because we know the limitations of Neurino, right? So it doesn't make sense for new implementers to not find this as a proposed standard RC. That's my take on it as an implementer. If I was looking for guidance from the IETF, right? I agree about the part about the process. I think we should revisit that process. I think ICCRG or other places could define what that process should be. But Cubic, given that it's already so widely deployed, I think, in my opinion, I would be very supportive of publishing it as a proposed standard.
Martin?
Just very quickly, I feel like we're getting maybe away from the 8312 discussion a bit, but regarding like the gates for congestion control, the bar that we were setting, it feels like that bar is now essentially high enough that the correct way to deploy new congestion control is to go work for one of those companies that Lars mentioned, deploy it at scale, and then come to IETF and say, see, it works, which maybe is not, it is kind of defeating the purpose of having this body or a related IETF body like provide review before things get deployed at scale. So I think we need to rethink it, basically, without making any specific proposals. Thanks.
Okay, okay. Corinne?
Yeah, I think I just want to respond to what Matt just said. If Cubic doesn't meet the bar, then I don't see that anything this group is ever going to do would meet that bar. So I think we should have published this as proposed standard years ago.
Okay. So do you think this is counting a number here is a good idea? Or this is too early or too controversial? Any opinion?
I think the general sense is that going on to proposed standard is justified.
Okay. So this is not the, how can I say, finalized number, but to think about how to proceed this draft, I just would like to count the number. So cubic. So if you agree with publishing cubic draft as a proposed standard, please raise your hand. Okay, 25. 26, 27. Okay, let's end here. Okay, then I can also get another information. So if you disagree with publishing cubic as a proposed standard, please raise your hand. Okay. Okay, good. I think 28. So
Can I just ask a clarification on the poll by jumping in?
Okay.
Did the last count include those people who wanted to publish it as EXP rather than just not publish? Because I think some people wanted to publish it as EXP.
Okay. Then I can add one more question. Okay, publish cubic as an experimental. How many people agree with this idea? One. Okay, number has changed.
Feel pressure at work.
Democracy and publishing interim results.
Oh, there it comes.
Okay, it's coming back. I can see some fluctuation. But okay, I think two. One. Please make your decision. I will close the poll very soon. It's okay to close the session. I will close. Okay, close. Okay, but at least I think we can get good statistics for this session. But still, this is not the final call. I think we should still continue the discussion. But I think I got a good data point. And okay, Colin, you want to make something? Make a comment?
No, hey, this is Lars. Sorry, I'm concerned now that I start looking like Gory. No offense, Gory. It's the mask, but it's the mask. Oh, Colin, sorry. And now it disappeared. Okay.
Sorry, I forgot to take myself out of the queue.
Yeah. I just want to, so for the authors team, ask that if people, because so we had the second working group last call now, right? If people are okay with publishing the version as is, that would be useful to know. And if the answer there is no, it would be very good to know what exactly should be added to the document. I know that Gori suggested earlier that we add a paragraph that said this document didn't follow the process outlined in whatever the RFC was. But the the IETF discussed this and I don't want to say approved, but at least acknowledge that it's not standing in the way of this publication or something like that. If there's other things that people want to add, that would be also good to know. I would like to ask the chairs for these suggested edits to a bit more actively ask whether there's consensus for this edition. Otherwise, we are sort of, again, in a situation where we have this grab bag of things that people want to add, and we don't really know what has consensus and what hasn't. Thank you.
Okay.
Martin Duke, Google. Yeah, Martin Duke, Google. If I recall the discussion, unless I missed something in the discussion, the only person who came to the mic and said it should be experimental was Lars attempting to be a sock puppet for Marku, like trying to like express his opinion without him being here. So if either of the one or two people who support experimental rather than proposed standard could actually like say something about it, I think that's sort of customary. At least to give them the opportunity to state their position. Thanks.
Okay, and so okay, then I would like to do final, vote. So publish Cubic as it is or not. This is last poll. You put a comment. Oh, it's some points. Okay, this is really interesting. Okay. There are several. Okay, Michael. You want to make a comment?
Yeah, Michael Welzel. Now, I'm afraid to say that because I'm not going to make myself friends with that. But I think the statement that Gori wanted, if that doesn't elaborate on what specifically is wrong about the document or what specifically these points were that Marco brought up that I think are important in some way at least, then that text is confusing to anybody reading it, right? So you have a PS RFC that says something's fishy here, but we're not telling you what. So I think that this text should actually elaborate a little bit on the specific issues that Marco brought up. Could be just an appendix, but I believe that text would probably be important to have.
Okay.
And now I'm hiding.
Okay. Let's stop the voting here. And BD, you want to make some comments?
Yeah, so I just want to reply to Michael that we have been making changes based on Marco's comments and writing those. If there are some open issues, we're writing or putting them in the draft for the reader to be aware of. At this point, it isn't clear exactly, like if there are suggestive texts that Marco or anyone else would like to add, would be really happy to add it. And that would require some participation and some commitment to make that to get that done. So there are lots of emails that Marco has sent, but what we have been asking again and again is if there is something you have a specific suggestion that we could add to the draft, that would be great. So we'll just it would be good to hear that.
Okay, so I did not want to make this complicated, and I haven't followed the last emails from Marco anymore, but I remember that there were things about having to update probably 3168 about something, and some procedural things, right, that he had heavy disagreement about. Now, I don't remember if that was all resolved or not, and I mean, okay, I'm fine with publishing without having that thing in. I don't want to make it complicated, I really don't. But if it's possible to state why there is a procedural problem here and why that thing gets published nevertheless, other than just saying, okay, it's published because there is code and it's deployed. I mean, if we could be a bit more elaborate than just something saying something's fishy about this RFC, then I think this would be valuable. If we cannot, I'm not going to make a point about that. I mean, it's okay. I still want. I think the primary thing is that this should be a PS.
Okay. Thank you so much. I think we have lots of discussion and we can get a lot of good data point. And we are running out of time. So I think we can, the chairs can discuss a little bit more about how to proceed to this draft. And so thank you so much, Billy. Now, yeah, let's move on to the next presentation. Bob?
So we are short in time. Please, if you can be faster than planned, that would be great.
Mm-hmm. Okay. That would be great.
All right. I've asked for a slide request. I don't know what happens.
You should make slide share request.
I have.
Really? I don't see. Oh, okay.
Share screen or?
Yeah, share screen.
Is it there? Oh, share screen. Okay. To be honest, I've never done that before. Okay. Can you now see it?
Not yet.
I can see a share screen request open.
Isn't it asked to share slides?
Yeah, that's what I thought. That's what I did, and then Yoshi said share screen. So
Can you try ask to share slides and then it will
No, share slide, sorry. Yeah, share slide.
Yeah.
Not share screen.
Yeah. Cancel screen request. Okay, hang on. It's responding very slowly, sorry. We will get there.
Time is running.
Yeah, I know. Yeah, okay. Well, I'll talk while we're waiting for this. This is sorry, it's saying, do you really want to share your screen? I've said no, and it's just hanging. Okay. This is going to be a talk about accurate ECN feedback. It's draft 18. Go away. There you go. Right. Now try that. Are the slides coming up?
Not yet.
Yeah. Yes, finally. Yes. Okay.
Okay.
Oh.
No.
It's gone again. A new slide deck is being shared, it's saying.
Okay. Let me share the slide.
We haven't. Okay.
There. We can see it.
Right. So am I controlling this or are you? You are, yeah?
Me.
Can you move on? Yeah. Yeah, so skip the next slide as well, which is a recap of that there's a 3-bit ACE field and 24-bit option, or with 24 bits plus headers. Next. Okay, so recent draft history. There was a long hiatus after July 21, but then like all good buses, they come in threes. And so February, March time. We've had 3. There's links there to the summaries of the diffs in each of them, which I'm not going to go through in these slides, but there are spare slides at the end that do. And thanks to Ilpo, Vidi, Gori, Richard, and myself actually for noticing some unclear parts, but I will go through most of those contributions. And also just to mention that there has been some conversation between the Quick authors and the Accurate ECN authors about how to deal with ACK frequency. So next. Just really news on implementations. There are 2 main implementations, one in Linux, one in FreeBSD. The Linux one is reasonably up to date, but it's a couple of draft versions out of date, but there aren't that many things to do. Richard's been implementing in FreeBSD. There's a link to his implementation there. It currently omits handling arriving TCP options, but it sends them. And I'm going to talk about that more later. Next. So this slide is about the main activity that's been going on recently on the list, based on a review comments from Vidi, asking about how you deal with any congestion feedback coming in when you're not sending ECN capable packets. So there are a number of cases where you might not send ECN capable packets because there's a handshake at the start that checks whether there's a mangling going on. And if there is mangling, you still remain in accurate ECN mode, but you don't set ECN capable on your packets that you send out. But then Vidi wondered, well, even if you're not sending ECN capable packets, what if you get congestion marking feedback coming back? And there are 3 possible ways we can think of doing this. A, B, and C here. In all cases, you would turn off sending ECN capable packets, but there's a difference in how we think you should respond to congestion if it comes in, as shown in the right-hand column. And we'd like some discussion either now or on the list of whether these the rationales for these make sense. So the first one is if during the handshake you see some sort of illegal transition going on, like either you send a non-ECN capable packet and you get back feedback that said that at the other end it was received with ECN capable, or you send it ECN capable and at the other end it says it was non-ECN capable but it comes back, etc., etc. Then you might think, well, it's not going to have any congestion response, but it might if the mangling is turning on ECN capability and then later on there is some congestion that is doing normal congestion marking. So the idea there is that you respond to congestion if you see any feedback, even though you wouldn't expect to see it, right? In the B case, if you see continuous congestion feedback, then you don't respond to it, especially if you're not sending ECT. But even if you are, that probably implies there's mangling going on that's asserting congestion experienced all the time. And the third case, C, if you get a zeroed ACE field, which is this 3-bit field, you shouldn't see that at the start. So that probably means a broken receiver or something's wrong. And therefore it's probably best not to respond to congestion and just solely rely on loss. So we've written that all up in the drafts. We went through a stage of having must and must nots for all those things, and then it was suggested that we should make them all advisory rather than normative, because with deployment experience, there may be unexpected things going on that an implementer needs to deal with. So we didn't want to tie things down too much. Okay, so that was quite a complex slide, but please respond on the list about any of that. Next slide, please. So in the process of these latest edits, I did a review of all the lowercase musts and shoulds and mays and recommended and things, and changed them all to needs to or ought to or might, so that they were not had no potential of being read ambiguously as potentially meant to be in capitals. There were just two cases where I changed lowercase recommended to uppercase, and I think they were justified. One is it said already in the introduction it's recommended to implement SAC and ECN++ with accurate ECN, and made that uppercase. And similarly, there was one saying it's strongly recommended to test the path traversal of the accurate ECN option. And given it already said strongly, I figured that was quite reasonable to put normative there. But if anyone wants to object to that, please do so on the list or now at the mic. Next slide. There are, as I said, spare slides with all the detailed changes, and I've also posted each one to the list. There are only really 3 technical changes. All the other changes are just trying to clarify normative text usually. The 3 technical changes are all that stuff I just mentioned about congestion response, if not sending ECT. Then there's a change where we've allowed 7 packets to go by before you have to send some feedback rather than 6, because the wrap is at 8. And we couldn't really think why we'd said 6, so we changed it to 7. We were just being conservative. And the third case is a bit of a fallout from when we changed the TCP option, accurate ECN TCP option. So we had 2 different TCP option orders. If you remember, we went through that episode of changing it. And we noticed that we hadn't changed the initialization of the 2 fields from how it was originally when we only had one option, one type of option. So we've changed that. Okay, next slide. A couple of upcoming changes. This slide, the first one. Gori's recently, very recently, been talking on the list about how he's not happy with this accurate ECN draft updating or RFC 3449, which is about network path asymmetry. And originally, I thought it should update it because it said, or 3449 said that ACK filtering middle boxes ought to make sure that 3168 feedback works. And so I thought, well, as we're changing 3168 feedback, we ought to update that advice as well. But there is an argument that that advice in 3449 isn't normative, so maybe we're not updating it. So I don't mind going with what Gori says, but maybe other people want to chip in on that point. But whatever, we're going to try and change the text to outline the problem and discuss possible ways forward without recommending any changes and without updating 3449. But if people feel strongly that we should update 3449, then please say. Next. Second upcoming change, and I think there's just one more slide. We're through the experience of Richard's implementation and LPOs, found that actually sending the accurate ECN option is the easier part of the code, and handling receipt of it is the difficult part. And so, whereas it currently says if you don't want to implement the accurate ECN option, at least consider implementing. If you don't want to send it, at least consider receiving it. We want to change that round to if you don't want to implement receiving it, at least consider sending it. And then that means that the other end, if they implement it, at least it will work, even if you're ignoring what they're sending you. So it gives a sort of immediate gratification for the host at the other end. If it implements it, it will start working for it. Okay, I think one more slide. So other than dealing with the two upcoming changes, one of which is still working through that filtering section with Gori, and then writing text for that. Please, could the people who asked for the recent changes just confirm they're okay on the list or not? And otherwise, I think we're ready for working group last call. And as I mentioned earlier, generalized ECN depends on this one.
Okay, thank you, Bob. So, Jonathan?
Please be quick at the mic.
Okay, two quick things. Previous slide, number 9. This proposed change would be the opposite of the interoperability principle, i.e. be conservative in what you emit and generous in what you accept. The other thing I would note, and I've put this on the list in the past couple of hours, is that I think the ACT rate request, which I think will be seen shortly, or talked about shortly, offers an alternative way of getting generalized ECN done. So we'll talk about that in more detail elsewhere.
Okay. Can I respond to both those? The first one, I don't think this is about liberal and in what you receive or send. These two cases, they're in either case, one end is not doing something and the other end is doing something. So I definitely don't think this contravenes that principle. But if you've said this on the list, I can respond there when I've fully understood what you mean. And the other case, I don't also see how the ACT rate requesting makes generalized ECN or does generalized ECN. It seems that generalized ECN is a different thing. It's trying to make control packets ECN capable, which I don't see how that relates directly to the ACT rate. But again, if you said that on the list, it comes from there.
Okay, Gori,
Gori.
Thanks for the RSC 3449 proposal on the list. I'm very happy with the direction that's going. I'm sure the rest of the document's pretty ready. The one thing I objected to, which you did not pick up on, was the strongly recommend. I'm not sure our AD would be that happy having a strongly recommend. Can you just replace that by recommend and say why it's so important? Because it is important.
Yep. Okay, I can do that. Yep.
Okay, so there still needs more updates, I think. Okay, yes, let's continue discussion a little bit more, and then we can think about if it's ready for working group last call or not. Sounds good, Bob?
Thank you.
Okay, thanks so much. So, okay. So moving on to the next presentation. Chorus.
So if you can be a bit faster than planned, that would be really great.
Yeah, I'll try. So should I ask to share slides or?
Yeah. If you want to control your slide. Yes.
I think we also need to get Bob's slides off.
Yeah.
I think
Yeah, because I'm seeing like I can control Bob's slides.
Wait. Okay, maybe. I think.
It shows me that Yoshi is sharing the slides right now.
Why sharing?
I just stopped
Okay.
sharing slides.
Yeah. Chorus.
Should I ask again to share slides?
Yeah,
or-
yes, it should work. Yes, again.
And we have some small voices in Ian's background again, I think.
Okay, I don't see my slides here for
They
whatever
are
reason.
coming up, maybe? A new deck is being
No,
shared.
it's-
So.
Oh. No.
Again.
I didn't find
Okay.
my slides on the list. Maybe if you can control them, Yoshi, or perhaps I can also share my screen, whatever you prefer.
Okay.
It might be easier to share your screen if you have it open. It's probably the fastest option.
Working. Okay.
Sorry. Okay, can you see the slides now?
Mm-hmm.
Okay, thank you. My name is Carlos Gomez, and I'm going to present the last update of the draft entitled TCP Upgrade Request, TAR option. My co-author is John Cookcroft from the University of Cambridge. First of all, let's take a look at the motivation for this draft. Delayed ACKs is a widely used mechanism which is intended to reduce protocol overhead. However, in some cases, it may also contribute to suboptimal performance. We can identify two types of scenarios here. The first is so-called large congestion window scenarios. That means when the congestion window size is much greater than the MSS, where saving up to one of every 2 ACKs may be insufficient. For example, in some cases, there might be performance limitations due to asymmetric path capacity. And also in some cases, we might want to reduce further the computational cost and network load. Then there's also so-called small congestion window scenarios. That means with a congestion window size up to the order of around 1 MSS. For example, this would be in data centers where the bandwidth delay product is up to the order of 1 MSS. And in this case, delayed ACKs will incur a delay much greater than the RTT. And also in transactional data exchanges or when the congestion window has decreased, the ability of requesting immediate ACKs may help avoid idle times, allow faster congestion window growth. So about the status of the draft, perhaps if you may recall, before creating the draft, there was some prior discussion on sender control of TCP ACKs, which appeared, at least to me, to converge to defining a new TCP option serving two purposes: the ability of requesting a given ACK rate and the ability of requesting immediate ACKs. So today I'm presenting version 03, which aims to address comments from Yoshi, Michael, Jonathan, and Bob. Many thanks for the very useful and helpful feedback. So let's go through the updates in 03. The first one is in the main format of the option. Previously, we had a 6-byte format, and now it's just 5 bytes. Basically, we have removed the field called n. Here, this was intended so that when r was set to 0, the sender could request immediate ACKs for the next n segments. However, it was found that this was mostly redundant, so it's possible to produce the same effect without an explicit field called n. And then also in the new format, the size of the R field, which corresponds to the ACK rate requested, has a size of 6 bits. And also there's one new bit which would be at the moment reserved. This is called V. So for the R field, there are like 2 possible encodings on the table. The first one would be like the straightforward approach, which is the binary encoding of the requested ACK rate, where the maximum value of R, since we have 6 bits, is the maximum value is 63. And then the second option is one of those which were suggested by Bob, where there would be 4 bits dedicated to represent a mantissa M, 2 bits for representing an exponent e, and then the requested ACK rate would be computed as you can see on the slide. And in this case, the range of possible requested values for R is greater, although there's better granularity for the lower values of R. Well, I don't know if there are comments on this, or perhaps we can discuss at the end. By the way, since I'm sharing my screen, I cannot see at all the queue. Okay. So, okay, so then we also have updates in section 3, which describes the behavior of the sender, the receiver. First, we state that at our option capable, receiving TCP should modify its ACK rate to 1 ACK every R received data segments from the sender. And this used to be a must in previous versions. However, it's been modified to should, because actually there may be several reasons why a receiver might not be able to satisfy the request. For example, lack of resources, also security, as I will mention later. Also, we've clarified that R equal to 1 means that the receiving TCP should send an ACK immediately, but R equal to 0 is not defined at the moment, maybe pending how we finally represent R in the field before. Then we've completed a bit the description of announcing support of the TAR option. And here, by the way, there was a suggestion by Bob about, well, considering due to the lack of space in SYN packets, that perhaps we might want to include the support of TAR option only in response to a SYN-ACK. So I don't know if there may be comments on this. Also, there was another suggestion to aggregate this option with others, as in Yoshi's draft. And another clarification is that a TCP segment carrying retransmitted data is not required to include a TAR option. So if the original segment carried a TAR option, the retransmission is not required to also carry the same TAR option. And then there have been several comments about the ignore order feature. Here, this was suggested once in a previous TCPM meeting. The idea behind the feature would be to allow a sender tell the receiver that it has some tolerance of R data packets. So then it's not necessary for the receiver to send immediate ACKs when there are like reordered data packets. However, it seems like the benefit that is seen from this feature is not so clear or not so significant. So the proposal that we have like on the table for the next update of the draft would be to just remove the feature. So I don't know if there's comments on that.
Martin?
Objections? Sorry, yeah.
Martin is in the queue.
Hi, Martin Duke Google as an individual. So on the Mantissa thing, am I correct in saying there's no way to express 0 without encoding?
Sorry, could you repeat?
On the Mantissa formula you have on the previous slide?
Yeah.
There's no way to express 0 in that encoding, if I'm not mistaken?
Yeah,
but
exactly.
Isn't 0 a part of the... Doesn't 0 have a meaning?
Well, it used to have, but now it doesn't have. Well, that's the
okay.
idea. Yeah.
Say no more. All right, next slide, please. So if you send the TAR in response to the SYN-ACK that is not sent reliably, so isn't that a concern?
Yeah, so that's one point. And well, I understand this was a suggestion to try to somehow deal with the lack of SYN space, but also perhaps we can just not consider this approach. Yeah.
Great, thanks.
Thanks for the comment. Yeah. Okay, so if there are no other comments, perhaps I may.
Okay. Yeah. Hi. One question. So so in case of option 2, the maximum value of R is 1024, which is very big. I don't know what kind of use case to have such kind of large value for R.
Yeah, I don't know if maybe Bob would like to reply himself, but it seemed like some people mentioned that the maximum value of 63 could be fine. However, Bob considered like the future, so when this option might be used several years from now, and perhaps the capacity of links change and so on. So I don't know if maybe Bob would like to also add something.
Bob.
The previous point about not being value zero, that feature of that attended because previously value zero did was valid because adding zero packets doesn't suggest you have to add one or more.
Sorry,
unless you're
your
trying to
audio
get
is
allow the
breaking.
to turn hacking simply.
Bob,
Your
I'm afraid you're
audio is
unintelligible.
Hang on, it's
very
better?
bad.
I'm afraid you're unintelligible. Perhaps if you put it in text
okay.
in the chat, then we can read it out.
Or put it on the mailing list since we are really short of time. Gory. Nope.
Sorry. We can't
Get
hear
it
you.
to the mailing list, please.
Yeah. Gori.
Gori Fairhurst, I favour option 1, and I don't know any method which is safe at 63. We currently have IW10. So how is bigger than 10 safe? It might be, but I don't understand how bigger than 63 would be safe by our current safety requirements.
Yeah, thanks for the consideration. So perhaps the point that Bob had was considering maybe not today's scenarios, but maybe future scenarios. So the idea was being able to support like larger values. But that may be, of course, something to take into account, that also a very large value may have issues, as you just explained. Thank you. Yeah.
Okay. Thank you so much. I think this is a good one. I think we got lots of feedback. People seems to be supportive. So let's continue the discussion and then update the draft. Thank you so much.
Okay.
And next presentation, Peng.
Okay, is my screen available?
Yep. Yes, sound is good.
But no screen. I'm starting sharing it.
Somehow.
It hasn't started yet, but you should be granted.
Okay. Okay, that's right. I think it will work, right? Okay. Hello, this is Pony from China Mobile, and I'd like to present the multipath TCP robust session establishment. And since this work has been presented in the past years, I'd like to have a recap of it first. This document wants to solve the problem of connection setup failure that is essentially caused by establishing a connection only on default path with unknown path status. When we use multipath protocol, the session will be established in sequence, and the default path is selected as the first one by default, usually maybe Wi-Fi. If there is no Wi-Fi signal, 4G or 5G access will be selected. However, when the Wi-Fi signal is bad and the delay is large, the default path can't be established, which will also affect the link of the second connection. So this problem is a real one and has been occurring during multipath protocol deployment and implementation. I believe some people have met this problem and pay attention to it. Moreover, even if the current document has a focus on MPTCP, we think it could be expanded towards MPQuick and MPDCCP support which has a similar initial path requirement. And here's the definition for a robust session establishment. It is a set of extensions to regular MPTCP and MPTCP version 1. It is designed to provide a more robust establishment of MPTCP sessions. It has 4 methods, including timer 1, SIM, and eSIM, and IPS. It also presents a design and the protocol procedure of the combination scenario, in addition to these standard alarm solutions. For example, the combination of the SIM and IPS, and the combination of timer and IPS. So a very short solution recap of those methods. First is the timer one. Resiliency against network outage is achieved by modifying the SIM retransmission timer. If one path is defective, another path is used. And for the SIM one provides the ability to simultaneously use multipath for connection setup. And RST is used to terminate connection setup on other paths when connection has been established on the fast path. And there's also the eSIM provides the ability to simultaneous use multiple paths. And join cap is used for decreasing overhead, merging all simultaneous established paths without join process. So the eSIM can be used for negotiation between both sides. And the final one is IPS provides a heuristic to select properly an initial path for connection establishment with a remote host based on empirical data derived from previous connection information. So this draft has been presented several times from IETF113, and the last presentation was in IETF110. The main issue is negotiating with chairs the possibility for getting rid of the IPR blocking issue towards adoption of it. So the criteria is something that authors can work on by taking to the other people who need the publication of the RFC and want the RFC. For instance, a presentation from the network operator other than DT with test result of the suggested mechanism would be interested input to the working group. So in this case, I found this work was really valuable and also planned for the joint testing work, but due to the COVID, it is too hard for us to find a place to do it. So I checked the test before, and it showed the obvious efficiency of this method. And there's also the history started from the 106. You can see the demo and the hexagon will be done in the IETF 107 and 108. So I just review the overall work, the draft hexagon demo and the IPR disclosures with the license. This draft is mature enough and completed, which my joining without IPR issue could help to promote this work. So I'd like to ask if we could call for adoption of this draft. Thanks, and any comments?
Steve, that's you.
Yoshi, will you go first? Or?
We can't hear you.
Yoshi, you're still muted.
Yeah.
So can you show the slide of recap 01?
0. This one?
Recap 01.
Okay.
And then, so it says that I would like to talk about criteria one. So it says, yeah, presentation from a network operator other than Deutsche Telekom. And then after that, with testing result of the suggestion mechanism would be interesting. So what we expect is not only showing support. This is good things. Showing support is very good thing. But um, what we really expect is showing some experience or operational experience or implementation experience, and then um, you can demonstrate that this is a great idea. And then at the same time, um, since you are not the author, we can know how you deal with the IPR issues. And that's kind of information will be very useful for us to think about how to proceed the draft. But just supporting is just one step, but we need more steps. That's my comment.
Yeah. Okay. Thanks. In fact, we plan the test and other more things, but haven't been success. Yeah.
So you mentioned that the idea can also be applied to MPDCCP and MP Quick. Doing connection setups simultaneously or via timers is something which is done in SCTP though. So there's prior art for other protocols. So does your IPR cover also MP Quick and MPDCCP? Or is your IPR specific to MPDCP?
I think it only cover MPTCP, but maybe the authors could clarify this question.
Because normally you write IPRs in a very wide scope. That's why I'm asking. And the other question is, for this stuff being deployed, is it needed to be implemented in an open source operating system, or is it okay if it's only implemented in proprietary systems?
Okay, thanks.
Okay, any more comments? Okay. Yeah, I think as I mentioned, that showing support from you is very good and for the draft, but it's still really difficult for we can think this is ready for working group adoption because as I mentioned, I want to see more broad support, or you can show some more solid test result or implementation experiment. Then you can convince people that this is good item for this working group. Right now, we just want support. So I think we need more support or more experiments. That's my take.
Yes, think we will avoid.
Okay.
Yeah. Okay. So should I stop to share the screen?
Yeah.
Okay. Thank you.
Thank you, Peng. So next, Maximum.
Yes. Can you hear me?
Yes, I can hear you.
Okay.
You have the 17 minutes we have left.
Okay, we'll try to make it a bit faster than planned to leave some room for discussion, because that's really the intent of presenting our work here in TCPM. So yeah, first we would like to thank TCPM for giving us the opportunity to present this draft for the first time within IETF. So this draft is called TCPLS Modern Transport Services with TCP and TLS, and you might be wondering whether TCPLS is an acronym. It's actually not an acronym, but it conveys the idea that we can bring TCP and TLS closer, and this has benefits, and we can bring new transport services with this combination. So I will not detail the content of the presentation. We will look at that just now. First, as an introduction, I would like to go back to two important protocols that have been designed within the IETF and that extended the transport services provided. So the first one is MPTCP, which started in 2009. And the first specification shipped into 2013 and enabled bandwidth aggregation with several subflows, failover in case of network failure with a make before break or a break before make mechanism, and it was made in a way that was backward compatible with TCP. Those were the main benefits of MPTCP, but it also had some issues. So the address exchange mechanism was not really secure, although it improved in V1, and it used TCP and the TCP options, which are prone to middle box interference, and so that really drives the design of MPTCP and made the design a bit more difficult to make. So MPTCP also proved to be maybe difficult to implement, and I think we can take the 7-year journey from this V0 specification to mainline Linux as an example of that. Of course, many things happen in that time frame, but still, it's a long time. So another important protocol that was more recently designed is QUIC, which started in 2016 with the goal of designing an UDP-based transport protocol, and which the first version of the protocol was shipped in last year, actually, and it enabled stream multiplexing without head-of-line blocking and connection migration and failover as well. And one of the key elements I see of the success of QUIC is the use of TLS to secure most of the QUIC header and the QUIC payloads, because that's really what enabled innovation to be brought back and effectively deployed in the transport layer. And QUIC can also be implemented in user space and shipped with application, which has a number of benefits. So I think an important point that we need to look at today is that we know that TLS is the most used protocol atop TCP. And the latest version is even expanding the use of encryption to extend the TLS protocol with encrypted TLS records and encrypted extension. And together with the fact that TCP support in the network and in operating system and kernel remains wider, TCP is also the fallback of QUIC currently still. So TCP will remain for a long time. And given the ubiquity of TLS and the lesson we learned when designing QUIC, the question I would like to ask is, or it's a rhetorical question, of course, but the question is, can we provide new transport services with TCP and TLS? And the answer in this presentation is of course, the positive one. We believe that by using those two elements, we can build an encrypted transport protocol that brings modern transport services. Those services are stream multiplexing, where the app can choose the degree of resilience from stream to others, resilience to head-of-line blocking. It can also offer connection migration and failover and multipath by scheduling at the TLS record level. This is something we will look, of course, into details with the protocol. So having this combined approach, we believe that the protocol can be more efficient than HTTP2, TLS, and MPTCP, because those protocols were designed on a strict layering assumption. And so it makes it hard for an application on top of HTTP2 to influence the MPTCP scheduling, but also taking into account the record level of TLS. So let's go over the protocol and put the focus on how we brought the services that we mentioned in this protocol. So let's start first with the session establishment, the TCP/LS session establishment. So one of the key facts is that TCP/LS does not modify the TCP or TLS handshake. What it does is introducing a new TLS extension that indicates the support of TCP/LS. So here, this extension is exchanged in the sequence diagram in the client hello extension and in the server hello extended extension. And at the end of the TLS handshake, both endpoints know they use TCP/LS. So the sequence diagram shows a regular TCP connection opening and a regular TLS handshake, but our proposal is compatible with TCP/TFO and TLS 0TT as well. So the first service I would like to introduce is stream multiplexing, and streams provides concurrent byte streams to application, and TCP/LS manage those streams and enables multiplexing over a single connection. So this is reminiscent of what HTTP2 brought to the internet. So if we look back at our diagram and see how it is implemented, we added a framing layer inside TLS application data records, which is called TCP/LS frames, and frames compose the record. And so if we look really closely at what happens on the wire when a TCP/LS receiver receives a TLS record, well, it first sees the header, which is in clear text, which indicates that it's a TLS application data records for the given TLS version. And then when it removes the protection, it has another TLS record here, which is the clear text record. And this record contains the series of TCP/LS frame. Here it's a single stream frame. We will not go over the details of the fields. I think all of you can recognize very strong similarities to what have been done in HTTP2 and in QUIC. So obviously, as you probably wondering now, those streams put on a single connection are subject to head-of-line blocking. This is equivalent to what have been achieved with HTTP2. So what we propose is also a way to for TCP/LS to manage several TCP connections in a single session and schedule the records across those TCP connections. And then by giving the possibility for the application to map the streams to connections, the application can choose the stream it wants to protect from head-of-line blocking from others. So here in our example, we have stream A and stream B on a single connection, and then stream C and stream D on another connection of the session. And so stream C and stream D will be protected from head-of-line blocking happening on the first connection and involving stream A and stream B. So this brings the question of how can we add TCP connection to a TCP/LS session? The mechanism we have designed involves the server giving tokens to the client and the client using those tokens to open a new connection. So here we have the server giving a token inside a frame. So this token has the value ABC and it has the sequence number 1. By controlling the number of tokens given to the client, and the server controls the number of connection. What the client can do is then open a new TCP connection and then use another TLS extension, which is called TCP/LS join, using this token value, and the server use this token value to identify and join the TCP connection to the TLS session. And then at the end of the token exchange, the connection is open and it has a given connection ID, which we will detail what it is used for in the coming slides. So the question now is, what kind of crypto material is used in this additional connection? So if we look at TLS, TLS encrypt each nonce using record using a unique nonce, and this is the nonce derivation that is specified in TLS 1.3. So this nonce use the record sequence to get the nonce of the record, and the record sequence is implicit in TLS 1.3. It is implicit because TCP delivers data in sequence, and so the sequence can be kept implicit. So as is, we cannot share this sequence among TCP connections of a TCP/LS session, because then the receiver has no way to know which record sequence the incoming records are. And so in the sequence diagram I've shown you some TLS message that resembles a TLS handshake, but actually we do not want to do a full TLS handshake and derive a new initial vector, for instance, because this is costly. And so what we propose is to change the initial vector nonce construction, and add the connection ID, so the ID of the TCP connection part of the TCP/LS session and XOR it to the upper bits of the IV. And by doing that and keeping a per connection record sequence, we now have back a unique nonce for each of the records sent in this TCP/LS session. So it's really a way to share the TLS session among several TCP connections. Another service we would like to provide with our protocol is a failover. And so in failover, the idea is that when a client has, here in our example, a client has opened a connection to the server and sends two chunks of stream A and stream B, and something bad happened to stream B, it never reaches the server, and actually the whole TCP connection is disrupted either by a middle box or by a network failure, for instance. So what failover enables the sender to do is to retransmit the frames that were lost onto a new TCP connection. It could have been established before the failure or even after. So how does this work on the wire? If we go back to our sequence diagram and look at what happens in this particular example, so we have the client sending two connection ID. We have the client sending, two TLS application data records over connection ID 0. And the second never reaches, as I explained, and the connection gets disrupted. The question becomes, how can the client know which one never reached the server and retransmit the one needed? And so for that, we introduce TCP/LS acknowledgements. And so those acknowledgements enable the sender to know which are the TLS records that were effectively received. We cannot rely on TCP acknowledgements because they just mean that the byte stream reached the receiver, but we do not know whether it was read by the application, whether it was stuck in the kernel buffers, or whether the decryption was successful. And so that's why we need those acknowledgements. So those acknowledgements identify records by stating their sequence number in the given connection. So it states the connection ID and the highest TLS record sequence that was received over this connection. So it only needs cumulative acknowledgement. So here in our example, the server could send an ACK to the client. Sorry, it states server CID on the right-hand side. It's supposed to state client CID. So the server sends back to the client an ACK and indicates that on CID 0, it has received up to sequence number 3. And then the client can make the right decision and retransmit the lost frames, and eventually those lost frames get acknowledged as part of the records containing the two ACKs on the bottom. So using all that, we are also able to do bandwidth aggregation simply by chunking a stream in some stream frame and then send them over different TLS records over the two connections. So I've tried to quickly present the protocol here. It's more explained in detail in the draft. We're very welcoming any feedback and comment on the draft, either on the protocol or the use cases, the services we presented. We will continue working on this protocol. There are obviously some part that needs to be discussed and designed. You probably didn't mind congestion control and flow control. We also do, of course. But also maybe looking at further ways to use the TLS extension to enable new services in TCP/LS, or even some how to make the receiver zero copy as in TLS 1.3, and all those kinds of stuff we're really interested in looking in the future. So the draft followed the preliminary version of the TCP/LS protocol that was presented in a paper at Connex 21 that you can read if you're interested in more details on our approach. We got also some early implementation feedback as we have implemented the latest draft. We've implemented it on top of a TLS 1.3 implementation in C called PyCo-TLS. This required us to modify 50 lines of the PyCo-TLS library, so to implement the IV nonce construction I've presented, and we were able to implement stream multiplexing, failover, and multipath in about 2.5K lines of C code. And this prototype will be released under an open source license in the coming weeks. So there is not much to say left in the conclusion, except that we are really welcoming any feedback and comments on our approach. And maybe one way to start discussing this work, because we're not looking for TCPM adoption, it would be to start a mailing list to discuss with interested people. So that concludes my discussion, my presentation. I hope we have time for discussion now.
Okay.
Thank
Sorry, one question. Okay, I want to make a very quick comment. So this is basic application protocol. It doesn't require any modification TCP. So
Right.
that means the focus of the draft is slightly different from focus of TCPM working group. In my understanding.
I think it's interesting for TCPM people because also people that participated in MPTCP have joined the group, and here we are touching on services that are addressed by MPTCP, and we believe TLS opens a new way to address those services. So that's why we think the presentation was fit here.
Mm-hmm. Yeah, it's certainly transport topic, but I'm not sure this should be the venue of the working group. But we can discuss later. Jonathan?
Jonathan Hoylands, Cloudflare. So first, obviously, it would be really nice to see this in the TLS working group. I feel like this is messing around with TLS in a way that we haven't seen before. But my question, which I've put in chat, is there a reason why you're doing something special with new TLS sessions rather than just using new session ticket and resumption to split out one TLS connection into multiple ones?
So this is also something we've briefly imagined, but we never really looked into that. Actually, the way we changed the nonce construction is quite simple and doesn't require the server to issue those, but issue a bit simpler values, which are those tokens I presented. But this is something we could look at, whether using this is more fit and requires less stuff to invent than our proposition. Yeah.
Yeah, because with TLS, it's seen lots of formal analysis and lots of like security work.
Yeah.
So inventing new bits and hoping they work is very scary.
No, but the change in the IV that we propose is very reminiscent of many discussion I've seen at the IETF. So this is stuff that they're considering for MP Quick, for instance. And I think I've seen some discussion in that part for DTLS, although I don't remember for which mechanism it was. Maybe key renegotiation or something.
Yeah, cryptanalysis by intuition is generally not recommended.
I get your comment. I get your comment.
Okay, we are running out of time. Any more comments? Okay, yeah, this is interesting idea, but yeah, we are still not sure if this is a topic for TCPM. So let's continue the discussion on the TCPM mailing list.
Of course.
Yeah, thanks so much.
Thank you.
Okay, thank you. So this is, we have all presentation. Thanks so much for your participation. Thanks so much for very productive discussion. So see you next IETF. Thanks so much.
Cheers.
Bye.
Yoshi, will you copy the notes?
Yeah. But I'm going to go bed right now.
Okay. Bye.
Bye.